Hello everyone and welcome back to Quantic Academy. Today we are doing P1 differentiation. Okay, so let's get started right away. What is differentiation? Differentiation is basically the process of finding the derivative. Okay, what is a derivative? Well, basically the derivative tells you the gradient of the function at every single point. So for example, if I want to know the gradient of the function at this point, I can look at the derivative and look at this point. If I want to know the gradient of the function at this point, I can look at the derivative and I know the gradient. If I want to know the gradient of the function at this point, I can look at the derivative and find the gradient. You get what I mean. So, why is it useful to find the gradient? Well, we know what gradient is, right? For a straight line, gradient is rise over run, or delta y for delta x. Okay? So why is it useful to find the gradient? Well, if we have a big gradient, that means the line is steep. It's going to look something like this. It changes quickly. However, if I have a low gradient, then as you can see, the graph changes slowly. It doesn't change quickly, it changes slowly. So if we know the gradient, then we know how much the function changes. We know the rate of change of the function, and that's useful because if you know the rate of change of the function, predict what's going to happen and stuff like that. Okay, so how would you actually compute the derivative? Now I'll get into the actual formula and stuff next episode, but we haven't learned. But we don't know how to do gradients of curves, right? But we know how to find the gradient of a straight line. Gradient of a straight line is just rise over run. It's pretty easy. So if we can somehow make a straight line out of this curve, we can find the gradient. Okay? So let's find the gradient at this point, for example. Okay. Now we want to try to have a straight line here so we can find the gradient. How are we going to do that? Well, as you can see, the function goes like this. If you follow my mouse, you see that the function goes like this, and it starts to increase like this. So at this point, if I were to approximate it with a line, it looks something like this. And actually, I prepared that line for you. It looks something like this. So this is how the function will look at that point, if I were to approximate it with a line. And this line is called the tangent line. Okay. So basically, the derivative of the function is the same thing as the gradient of the tangent line. Right? Okay. Now, the last thing, let's look at notation. So if you're given a function in terms of f of x, then its derivative will be written as f dash x. This is pronounced f prime of x. That's its derivative. If you're given a function like y is equal to something, let's say y equals x squared, for example, then its derivative will be written as dy over dx. The d represents delta y, and this one represents delta x. It's basically to show you that this is the gradient. Okay. Now, last thing, I lied, that was not the last thing. This is the last thing now. Second derivative. Now, what's the second derivative? Well, you just differentiate the first derivative. That's basically what the second derivative is. So if the first derivative tells you the gradient of the function, so the second derivative will basically tell you the rate of change of the gradient of the function. And from that, if you can work out like how much the gradient is changing, you can work out pretty much the shape of the function. Okay, so the second derivative is written like this. So the first derivative had f dash, second derivative f double dash of x. We say f double prime of x. Again, if we had y instead, then first derivative dy dx, second derivative will be d2y over dx. Okay. So that's it for today. That's it for the first part of differentiation. Next episode, we will go over some examples and how to actually differentiate. Thank you guys for watching.